Oh, I know what I did. I have no sound. It's me. Hey, this is assignment 1-4. Here we go. So assignment number 141. Can you understand to evaluate a limit or a function value off the graph? So the limit as x approaches 5 for this. Find where 5 is. I found it. Now go to the actual graph from the left and from the right. What's the y coordinate it's approaching? And the answer is -2. Here, in fact, we'll do it properly on here because this is what I want you to do. Write down assignment 1-4 for question number 1. The limit as x approaches 5 of f at x, and we said the answer is 2. All right, question number 2. The limit as x approaches -3. I know it's blurry. Of f at x. Maybe it'll clear up. There, it clears up. Looking off the graph. So find where -3 is. I found it. Now, we have a graph below and we have a graph above. If I look at the left compared to the right, on the left it's approaching 2. On the right it's approaching -2. There's a big jump there, and a limit doesn't exist where there's a jump. Does not exist. Here we go, number 3. The limit as x approaches -3, but now from the left. So because of that little negative sign, so if I'm looking on the graph, from the left, the y coordinate is 2. And I bet you the next one is from the right? Yes. So the limit as x approaches -3 from the right. From the right, when I look off the graph, that's from the right coming, so start on the right and then work your way towards -3 from the graph. What's the y coordinate there? And the answer is -2. And then in question number 5, it's just what's the function value at -3? So not a limit question. So the function value is not the whole, but actually the point there. So at -3, the point, the y value is at -2. Number 6. The limit as x approaches 4 from the left. Find 4. There it is. From the left, it's going to infinity. You could also say it does not exist because it's impossible to approach infinity. However you want to see it. Both are correct answers. Number 7. The limit as x approaches 0 of f at x. So look at 0. And then think, what's the limit there? So both the left and the right agree the answer is +2. Number 8, what's the function value at 0? And that answer is also 2. That's a definition of continuity. So if the limit value and the function value are the same, then that is continuous at that point. So you can have a function value, but there's a jump right there. This shows there's no jump, and it's continuous. And there's a calculus definition of continuity. All right, the limit as x approaches 4. So find 4. Notice on the left it goes up, and on the right side it goes down. They're going in opposite directions, so that means it does not exist. Number 10. The limit as x approaches 4 from the right. So if I look at 4, but from the right, you could say it's -infinity on the right side, or it does not exist. Number 11. What's the function value at 4? Well, at 4 we have an asymptote, so there is no function value. So f at 4 is undefined. Number 12, what's the function value at 2? So look at 2, not the whole, but the point. So the answer is -2. If I did a limit question, here it comes. So what's the limit value? This is the big question for this lesson. Do you understand the difference between evaluating a function and a limit? So what's the limit value as the function is approaching to? So when I look on the right and the left, it's approaching 0, even though the function value is down here. So the limit value is 0, and therefore it is not continuous at 2. Notice the function value and the limit value are not the same, therefore it's not continuous there as at 2. 14. The function value at 1. Oh, I went dark. So the function value at 1, here we are, there's 1. There is no function value. There's a hole, and there's no point above or below it. So it doesn't exist. It's undefined because it's a hole. 15, the limit as x approaches 1 of f of x. So again, notice the function value is undefined, but the limit value, what is it approaching? And it's approaching 1 from both sides. So the limit exists, but the function value doesn't exist. For the limit, the question is approaching. And then the function value, what does it actually equal? All right, number 16, list the x values of removable discontinuities. Now, if it's a removable discontinuity, that means the limit exists at that discontinuity. So like for instance, -3 is a discontinuity, a jump, the limit doesn't exist. But look at +1. There is no jump there. The limit exists there, so it's removable. So at x equals 1, here again, it's a removable, and notice the limit exists. That's the real one. If it's removable, the limit exists. So the limit exists here. So also at 2. And here we have an asymptote where it's for a discontinuity, and the limit doesn't exist there. So those are called removable discontinuities. And then 17 says, what are the x values where they're non-removable? That means the limit doesn't exist where it's not continuous. So if something is continuous, you could take your pen and you could just draw it and the pen would never lift up. It's continuous. Here we have a discontinuity and the limit doesn't exist. Why? Because there's a jump there. So at -3, where else do we have a discontinuity? We already said 1 and 2 are removable because the limit exists. At 4 would be another discontinuity that is non-removable because the limit doesn't exist there. All right, number 18. In number 18, use the graph to find each value. The limit as x approaches 0. So go to the graph and the y value is 2. And then the question for B is, that's A, for B is the limit as x approaches 2 of f of x. So find +2. The limit is the y value, so it's approaching. There's not even a discontinuity. So if it's continuous, it's just the function value, which is 0. What's f at 0? There's a hole there, so it doesn't exist because there's a hole. Whoops, there we are. There's a hole there when x is 0. And then what are the removable discontinuities? So right here, when x is 0, it's removable. And why is it removable? Because the limit exists at that discontinuity. So if the limit exists, then it's removable. If the limit does not exist, it's non-removable. All right, number 19. So looking off this graph for number 19, we'll go through this. So the limit as, yes, you can come in. Here, I'll stop it. All right, I'll continue this video in a second.